Hi there, it's Space Nuts yet again. How many are we up to now? 474. My goodness, it's a Q&A edition. My name is Andrew Dunkley. Thanks for joining us. This time we are going to be answering questions about what constellations look like from a different point in space. If you're traveling, when does it not look like your neighborhood anymore? It's an interesting question. We're going to talk about a comet that's been in the sky recently, and I've seen lots of happy snaps from people on the Space Nuts podcast group Facebook page about this Comet Tsuchinshan. We'll also be discussing the age of the universe and citizen science. That's all on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to answer all of those questions, it is Professor Fred Watson. Hello, Fred.
Hello, Andrew. Amazed to see you here. It's very good.
Yes. How you been since I saw you last?
Sitting here, really. Just waiting for something to happen.
Yes,
haven't moved.
Funny. Shall we get stuck straight into it?
We should, yeah. My coffee's going cold, so we should.
Oh, yeah. Get into that. We are going to New York first. This is a question from Roger.
Hey, this is Roger. I'm a truck driver. Tonight I'm traveling through the Adirondack Park in upstate New York. I got a question about the constellations. I'm guessing that anywhere in our solar system you went, they pretty much look the same. But how far would you have to go before things start to get disoriented? We were to go to Alpha Centauri, like 4 light years away. Would you still recognize some of them, or would they be completely disoriented? And I'm kind of thinking of like science fiction shows where they show the stars flying by like trees when you're going down the road. I'm kind of guessing it wouldn't look like that because of the distance between them. They probably look like they stayed in the same place. But well, the question is, how far can you go before you don't recognize the neighborhood anymore? All right, loving the show, guys. Keep on trucking.
There he is. Thank you, Roger. Always love that. Haven't heard from Roger in a while. That was an interesting analogy about driving down the highway and the trees fly past. They do portray space travel that way with the stars, but I think it would probably be a much more boring view than that in real terms after a while. I mean, it'd be pretty extraordinary to look at, but eventually you'd be saying, oh yeah, there it is. That star's still there. Yeah. I might check it in 1,000 years' time and see where it is. It might be a bit like that.
It probably is, actually. I mean, first of all, we, on human timescales with the technology that we have today, it takes a long time to get even beyond the orbit of Pluto, as we know from New Horizons, which I think took 9 years to get from Earth to Pluto on its epic voyage in the early part of this century. And it is interesting that that has been used as a baseline to directly measure the distance to some of the stars. The fact that we know where a star is from the Earth, and you get to 30 astronomical units, something like that. The distance out to Pluto is 30-40. And an astronomical unit is 150 million kilometers, the distance from the Earth to the Sun. To get a view from there, their positions look very, very slightly different. You need to measure them accurately with the kind of equipment that New Horizons has on board. But yeah, you can see the difference there. You can see what we call the parallax, the different position in the sky that a star looks to be from different things. Yes, and the name of a well-known book by an author who has a voice very similar to the one that you're not listening to now, but you will be in a second.
I think I know him. Yes, I just happen to have a copy of the book on my desk, as you mentioned earlier. So there you are.
Yeah, it's a great word and a great title for a book. But, Roger's comments are right on the money. You've got to go a long way before the constellations start looking different. I think if you went to Alpha Centauri, you'd look at the sky and think that's pretty well the same sky that we see from.
Oh, really?
Except for the Alpha Centauri itself, or the Alpha Centauri systems is a triple star system. That would look pretty damn bright. And so you wouldn't really see the stars of Centaurus. But a lot of the stars in the sky are at distances which you measure in hundreds of light years. I guess with the naked eye, we see out to about very roughly 1,000 light years. And so traveling just 4 and a bit light years is not going to change things that much. There'll be some constellations that will have the odd star looking as though it's in the wrong place. And Centaurus will be one of them because you're right next to one of the stars of Centaurus. But I think generally speaking, you will be able to recognize them. They might look just slightly warped, but you'll be able to recognize them. It was certainly a common feature of textbooks that I used to read on astronomy when I was a youngster growing up and getting interested in astronomy. It's a common feature to have pictures of constellations as they are now, as they would be in 10,000 years, as they would be in 50,000 years. And so it goes on. And that's because of the intrinsic motions of the stars themselves. It's not because we're changing our vantage point. But it was always the same. You could see the basic outline of a constellation and it would just change slightly. It's sort of, you realize that it's not quite the same, that something's a bit different about it. So I think that will be what you'd see as you journeyed deeper and deeper into space.
Yeah, so you'd have to go a heck of a long way before you really sort of went, where the hell am I?
Yeah, I think 50 light years, 100 light years, you would start seeing a completely different set of star patterns. You really would worry where you were. This would be a very alien sky to you.
Yes, indeed. But a really interesting question, and
that's great.
And not surprising that it's come from Roger, who spends a lot of time traveling, and he probably was driving along and the trees were flashing past, and he went, "Wait a minute!"
Yep,
there's a question in that. So there it is. Thank you, Roger. Well done.
Roger, you're loud and clear here also.
Space nuts.
Our next question comes from Lisa. Lisa is from Prince George in British Columbia in Canada. Hello, Professor Fred and Andrew. I was lucky enough to have clear skies to see Comet, I'm going to get it right this time, Tsuchinshan. Was passing by and got to observe it 2 nights in a row. I shared a few pictures on the Space Nuts podcast group Facebook page. If anyone is interested, I probably saw them. Lisa?
I did too.
Witnessing such a rare event was truly awe-inspiring, and it got me thinking. We know this comet has an orbital period of 80,000 years, but do we know for sure that it's been here before? Is it possible that it dropped out of the Oort Cloud more recently and is on its first lap, so to speak? Is there any way to tell, other than direct observation, if a comet is a repeat visitor? Thanks for a wonderful podcast. I've been listening since 2018 and love both the show and the community that has formed around it. Lisa. Oh, that's lovely, Lisa. Glad you're enjoying being part of the Space Nuts podcast group on Facebook. And if you're not yet, maybe you should go along and have a look, because it is a great little page. And I think everyone really enjoys their time there and their company and the conversation they have with each other. However, we have an important question to answer with Tsuchinshan, the comet that was in the sky recently. On the nights I was best able to observe it, it was cloudy, and then when it finally cleared up, the darn thing was too low on the horizon for me to get a look at it. So I never ever got to see it myself, which I'm very disappointed about. But I'm pretty sure it won't be the last one to pass by in the next several years. So I might get a shot at another one.
Oh, you will. And I've got a similar story to you, Andrew, which is that when it was at its brightest in the evening sky. Here in Sydney, we had really overcast weather, which we've got now. It's been like this for a month. and it's not very conducive to astronomy. But I was lucky enough when we were, I think I told you, Manny and I were down at a place called Sea Lake near Lake Tyrrell in northern Victoria for a star fest, and there were lots of telescopes there. And one of them had one of the astronomers who was using these telescopes had his telescope coupled to a detector, a real-time detector, in other words, a TV camera, and he was showing the results on a screen, and he was actually pointing it at Tsuchinshan. And so I did see it, but not through the telescope, but I saw it live as it was on the screen. So that cheered me up quite a lot. Now, to Lisa's question, that's a really good one as well. And this business of the 80,000 years, it's a little bit of a movable feast because comets are often, their orbits are perturbed strongly by the gravity of other objects in the solar system, including, in particular, the planet Jupiter, which is, the biggest of the planets. And so often the orbital period of these very long period comets changes. Now, to the nub of the question, could this be its first visit into the inner solar system? I think it could be. I'm not sure in this case, and I should have read up on this, because there are markers in a comet's emissions when it gets near the sun that give you some idea as to how many times it has been round the tracks. In other words, how many times it's passed close by the sun. Because it changes the structure of the comet. Every time it goes around the sun, you get more of the volatiles blown away, and you're left with a more dusty body. And I think there's, the rate at which these chemicals, the elements within and molecules within the comet's icy body, the rate at which these are dispersed into space changes depending on which compound you're talking about. And so I think by looking at the mix of chemicals that is being emitted by a comet when it gets near the sun, you can get some idea of how many times it's visited the sun. Now, I'm only saying things that I recall from having looked this up a long time ago. So there might be nuances in that aren't correct, and there might also be details that I haven't really explained. But the bottom line is that it may have been the first time around the sun. If not, we might have ways of knowing about it. And I should check them out just to see what the pundits say about that.
Yeah, well, it was only discovered last year.
That's right, it was. So it was on its incoming orbit last year, so we know.
But the first thing, I just did a quick search, and I've said, has the comet been here before? And it says it has never reached the inner solar system in human history before now, apparently. So there you are.
So
good call for it.
It's a pristine comet. That's what I thought.
Okay, so we just have to wait 80,000 years to have another look at it.
And see what's changed.
Yeah.
Yeah.
Yes, indeed. There's a few that are going to be quicker than that. That's the good news. Yeah. Thank you, Lisa. Though, really good question. And yeah, you're right. It's the first time it's been here, apparently. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, to our next question, although we're not moving far around the globe, because this one comes from David, who happens to live in Canada.
Hello, Andrew and Professor Watson. David here from St. John's, Newfoundland, Canada. Just wondering, how did we measure how old the universe is? Thanks. Love the podcast. Bye.
Thanks, David. I'm going to ask David a question that every time I travel and I tell people I'm Australian, they'll say, "Oh, do you know John Braithwaite?" So, David, do you know Lisa? No, I gather from the provinces they live in, they're probably not very close together at all. But I get that a lot. I get that a lot when I travel. It's ridiculous. Well, I might know him, except there are 30 million other people that, Oh, yeah. It's funny. It is funny. Age of the universe. How do we know it's right? How did we measure it in the first place? What's the goss there?
So, so the first measurements made of the age of the universe were when we started measuring what's called the Hubble constant. And the Hubble constant is the current rate of expansion of the universe. It's how fast it's expanding now. And it's an easy calculation to go from that. If you assume the expansion has been constant throughout the history of the universe, it's an easy calculation to go from the expansion velocity back to when everything was at the same point in space. And you get the answer. You get an answer of about, if I remember rightly, it's about 15 billion years. So that was the first way that we evaluated the age of the universe. And I guess that was in the early 60s, 70s, when the Big Bang Theory was really becoming very much the theory of the universe as we know it, rather than one that was just a hypothesis. So that's the first way. But there are other ways of doing it, and you can sort of again, it's all about accurately measuring distances and things of that sort, because that's what you need to do to get a good idea of, well, first of all, the Hubble constant. You've got to evaluate what that is, and it needs the measurement of distances. And there are two ways of measuring distances in this kind of context. One is standard rulers, and the other is standard candles. So a standard candle is a light source that you hold up, whose intrinsic brightness that you know, and then you see how bright it is from your vantage point. And if you know the intrinsic brightness, you can work out the distance. And that's how the supernova works. People are doing investigations of in particular, the dark energy and the accelerated expansion of the universe. They look at supernova explosions of a particular type that we know has a certain brightness. And from that, you can deduce the supernova's distance. And from that, you can tell whether your value of the Hubble constant is right or whether it needs tweaking. And the standard ruler method actually goes back to the early universe, when there are characteristic separations of galaxies. And even before that, the characteristic separation of the hot and cold features, or the warm and cool features in the cosmic microwave background radiation, give you an idea about the age of the universe, the state of the universe at that time. So all these things come together, and you've got a much more subtle value for the age of the universe. We now think it's 13.8 billion years. But that's not that different from just taking a straightforward, linear expansion since zero to determine the age of the universe directly from the Hubble constant. So 13.8 billion years, it's got a lot of input into it, but even the crudest method gives us something similar to that.
While you were talking, I thought I'll do a Google search, and I asked, what is the exact age of the universe? And the answer was interesting. According to estimates, the universe is 13.7 billion years old with an uncertainty of 200 million years. So we can't really be exact, can we?
No, that's right. So our technology has to improve. I have always had not a theory, but the notion that when we do get down to the exact age of the universe, it will turn out to have been created on the 1st of April. And that will tell us things about the universe that we probably don't really want to know. It's just one big joke.
Yeah.
Oh, how we laughed.
Yes, imagine so. So there it is, David. Several ways of making the measurement, and they all come up with around about the same number. Finally, Fred, we have a question from Sandy. I love these short form questions. Hi, Fred and Andrew. Are there citizen science programs that you know of where average people, i.e. me, help with scientific data for asteroid occultations and light curve data submission for stars and asteroids? Wow. Thanks, Sandy.
Yes, another great question. And good on you, Sandy. That means you're making measurements, and citizen science is a great way of getting those measurements into our knowledge base. So the first thing that came into my mind was the Zooniverse. And Zooniverse is a kind of suite of citizen science programs that started, I think, with the Galaxy Zoo project, which was citizen scientists looking at images from the Sloan Digital Sky Survey, and that's a telescope in New Mexico that surveyed the northern sky in very great detail, discovered all these weird and wonderful objects, and they, among them galaxies, the weird and wonderful galaxies is probably what mostly this was about, hence the name Galaxy Zoo, which produced some quite extraordinary discoveries. Hani's object is one that comes to mind. I think we might have mentioned that recently. A green blob next to a galaxy, which was eventually traced to gas fluorescing after an outburst from the center of the galaxy, probably a burp by the black hole at the center of the galaxy, some millions or even billions of years ago. Hani's Oort, it was called, because I think that's the Dutch word for object, and she was a Dutch school teacher. She probably still is. So that sort of thing was a particular version of citizen science, but that sort of spread its tentacles and became something called the Zooniverse, which I think has a number of different projects in it. And I think there may well be asteroid occultation pages or data light curve pages. I actually just Googled citizen science asteroid occultations and came up with a number of interesting websites. Unistellar has one, Unistellar Citizen Science. Unistellar is a company that is actually manufactures a very particular kind of telescope, and they have an asteroid occultation citizen science page. That's one to look for. I also Googled light curves, I think, citizen science light curves. That came up with a whole lot of things. One of them is actually, the Hubble telescope has global citizen science projects of its own. But Zooniverse is perhaps the classification that's biggest and perhaps most popular. And they certainly do have a variable star light curve citizen science project. There are specialist astronomical societies that do both of those things as well. There's societies dedicated to asteroid observations and dedicated to variable star work. So most of them are international and very well established, and they're not that hard to find. So have a look around, Sandy, and you're sure to find the right one for you.
Oh yeah, I thought I'd just throw one out there and say, what is the greatest discovery by astronomical discovery by a citizen scientist, and it went straight to an August 2024 article in phys.org. Citizen science projects identify 20 new astronomical discoveries, and that included previously unidentified supernovae. And there's more than 2,000 volunteers across 105 countries that are working on these projects. The project is called Kilonova Seekers, and they're aiming to find kilonovae, the cosmic explosions of neutron stars and black holes colliding in distant galaxies. So there's all sorts of stuff going on out there. If you search deep enough, you'll find what you'll find more in terms of citizen science in the realm of astronomy. So there's a lot going on. I don't do it with astronomy, but I do a little bit of a thing that's not, I don't suppose you'd call it citizen science. I downloaded an app called DreamLab, DREAM Lab. And what it does is at night when I put my mobile phone on a charger, I open up the DreamLab app and I just click start session, and it starts crunching numbers using my phone as part of a giant computer to sort out whatever scientific problem somebody's trying to solve. The last one I did, which took 2 years to crunch, was a COVID-19 calculation.
Interesting. Yeah.
Right now, I'm doing one through DreamLab supporting the Tropical Cyclone Modeling Phase 4 study. So it's all sorts of subjects that you can.
That's amazing stuff.
Yeah. Cell Identity Hunter, Phase 2, which is an Italian study. The Imperial College London is doing a study on long COVID. So if you want to use your phone for very positive reasons, you may find astronomical studies that you can do through a mobile phone app, or if you want to help in so many other areas, just have a look for DreamLab. DreamLab with a little purple cloud is the icon. I basically let whoever use my phone when I'm asleep to crunch calculations. So it's a good way to use mobile technology for the greater good, I reckon. But Sandy, I don't think you'll have any trouble finding citizen science groups in those areas that you asked about. Thanks for your question. And if you do have questions for us, go to our website and send them to us there. Just click the AMA tab on the spacenutspodcast.com website and send us your text or audio questions there. Don't forget to tell us who you are and where you're from. Just lately, they've all been from Canada or Brisbane, as it turns out. But I'm sure other people around the world send questions, as will Geordie, who's always asking for dinner. And Fred, thanks so much for your company and answering those questions today. It's been good fun.
Yeah, thanks again. I think Geordie's telling me it's time I gave up on this. Time for a walk. So thank you very much, Andrew, and we'll talk again soon.
We will. Professor Fred Watson, astronomer at large, and to Hugh in the studio, nothing much to say there, no movement at all. And from me, Andrew Dunkley, thanks for your company. See you again, and Geordie, on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.